All right, you guys. Today for 7.2, we are going to talk about congruent triangles. I forgot our essential question. Let's just write it in. Essential question of the day, how can I prove triangles are congruent? So by the end of the lesson, we're going to learn a bunch of different ways you can show that two triangles are congruent to each other. Before we get into any of that, I do want to talk about classifying triangles, either by their sides or their interior angles. So you guys, if you have a triangle that has three different side lengths, like none of them match up with each other. Here, we'll use three different colors. Three different sides. This is called a scalene triangle. Yep. If you have two sides that are congruent in a triangle, here, two purple, and then the third one is different, that is called an isosceles triangle. And the third one, if you have a triangle where all three sides are the same, this is called an equilateral triangle. So that's three different ways to describe triangles by their sides. I think the most commonly forgotten one is the scalene. That seems to get people. The second set of triangles are all classifications based on their angles. So first up, an acute angle. An acute angle is less than 90 degrees. So if all three of these are less than 90 degrees, I think you just call this an acute triangle. If there is one right angle in a right triangle, or excuse me, in a triangle, this is called a right triangle. If you have an angle that is bigger than 90 degrees, one obtuse angle, so this is greater than 90 degrees, the opposite of acute, this is called an obtuse triangle. And the last one is a very fun math word where if all three angles are the same in a triangle, this is called equiangular. Equiangular triangle. So scalene, isosceles, equilateral, acute, right, obtuse, and equiangular. And you can have like combinations of these too. You can have like an obtuse isosceles triangle. Like I could draw that. Like, you know, if I make two sides that are the same, like this, and then connect them with a third side, like that's an obtuse isosceles triangle. Ooh, big fact that might come up at some point is all interior angles in any triangle always add up to 180 degrees. Now, you guys, if two triangles are congruent to each other, that means that all angles are congruent to each other. I mean the corresponding ones. Yeah, so all these colors match up with each other. And then corresponding sides are also congruent. So this would be the same as this. And then like this one would be the same as this. And the last one, this side is the same as this. So if all six parts, the interior angles and all the sides, the triangles are congruent to each other, but you don't need all of that information to say, hey, these two triangles are congruent to each other. There's shortcuts. You don't need all 6 bits of information. You can have just a few of them and then go, oh, well, the rest must be equal to each other because these certain parts are equal to each other. So we got a bunch of triangle congruences here. The first one is called side-side-side, or more commonly, a lot of people call it SSS. So this means that this side is the same as this side, this one is the same as this one, and then the third one also matches up. So if you have all three sets of sides congruent to each other, then the angles must be congruent to each other as well. So here we would say triangle ABC is congruent to, now remember the path thing, that if you go A to B to C, then that's going to be T to R to S. Not RST, but triangle TRS. So that's the SSS, side, side, side. There's also a side angle side. This one I like to call the angle sandwich. Delicious. The angle sandwich is if you have an angle like this, that's the same in both of these triangles, and then these sets of sides are also congruent to each other. Do you guys see how this side, this angle, and this side, that the angle is like sandwiched between the two sides? So here it's an angle sandwich as well. If you have an angle sandwich in both of them where it's side, angle, side, and they all match up and congruent to each other, you can say that the two triangles are fully congruent to each other. So this would be triangle RST is congruent to triangle UVW. There's two more triangle congruence shortcuts or postulates, whatever you want to call them. There's the angle side angle, which is the ASA. Now, if the last thing was an angle sandwich, this one is a side sandwich. What I mean by that is that if you have this angle, the same as this one, this side, the same as this one, and then this angle, the same as this one, notice that it's like angle, side, angle, angle, side, angle. So it's a side sandwich because the two angles are touching both parts of the side. If you can show angle, side, angle is congruent to angle, side, angle in another triangle, then the two triangles are fully congruent. So I'm going to say triangle BAC, watch your order on these, is congruent to EFD. I guess I could say by ASA. Yeah, let's maybe add that to these up here. Like this one is congruent by side, 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 and this one is congruent by SAS. And you can just use those three-letter combinations on those. You know, if we ask you why are these two triangles congruent, you can be like, oh, by SAS. The last one is angle, angle, side. And it really, the order is so important here, you guys. If this is an angle that matches up with this one, and then another one where these match up, and then this is the side that they have in common. So here it's the order of angle, angle, side. Angle, angle, side. I mean, yeah, you would go kind of the shortest path on these, because I realize some people look at this and they're like, well, Mr. Jolly, couldn't you go the other direction? Isn't this angle, then side, then angle? But that's not the case, because you kind of jumped over too much when you went from here around to this side. You always take the shortest path of least resistance. So when I do that, it's like going this direction. So that is angle, angle, side. Angle, angle, side. So the congruent statement here, let's say triangle LNM is congruent to triangle OPQ by AAS. Now, just a quick note before we do some examples. There is no AAA, there's no SSA, and there's no ASS. Yeah, just remember, like, you can't use bad words in math class. So there's no ASS, there's no backwards ASS, and there's no AAA either. Those do not work for triangle congruence. So if you show that it's like, well, this side, this angle are the same in both of them, it's like, wait a minute, no, there's no ASS or SSA. Those do not prove congruence. Let's do some examples. First one, can you show that the two triangles are congruent? If so, how? You guys, when I look at this, oh wait, they're kind of twisted. Ooh, interesting. So here, this angle matches up with this one, and then this angle matches up with this one, and then the third side is this is congruent to this. So yes, you can say these two triangles are congruent. So we can say triangle ABC, that's a B, is congruent to triangle QRP. And the reason is because of angle side angle. Because it's angle, then a side, then an angle. It's a side sandwich. Angle, side, angle. Next example. Prove that these are congruent if you can. When I look at this, I see side, side, and then an angle between. Oh wait, that angle's not between. Ah, tricky, okay. So this is the classic, like the order really matters. So like at first glance, you're like, oh yeah, it's like an angle side angle or a side angle side or something like that. But notice that here, that the angle is between the two sides, and over here, that angle is not between the two sides. So we cannot say these two triangles are congruent. Next one, let's see. Well, we have an angle that matches up with an angle, and then a side that matches up with a side, and then another side that matches up like that. The mistake that some kids will make with this is they'll go, well, yeah, look at the order, Jolly. It's a side, angle, side, and it's a side, angle, side. But when you do that, you have skipped over part of the triangle. Like you're kind of jumping this side, and that's not cool. So this is actually like an angle, side, side, angle, side, side situation. And remember, you cannot spell the bad word in math class. So these are not congruent to each other. Can't prove that they're congruent. Oh boy, here we go. You guys, there's a property that we haven't really talked about yet, and I thought I'd talk about it a little bit. If you have an angle that's directly across from an angle like that, and these two make like a giant X together, these are called vertical angles. So vertical angles are congruent to each other. So when I add those markings in, we can say that we have an angle, a side, and a side, and then another angle. So you know what? The order on that one is angle, side, angle. It's a side sandwich. So yes, they are congruent. Let's say triangle ABC is congruent to triangle ECD. Remember, the order matters there. So if I went ABC, oh no, wait, I did do ABC. Hold on, I messed this up, you guys. And that B looks terrible. I'm redoing it. So I went ABC. Let's look at the order of that with a different color. A to B to C. Well, if I start with the double over here, the double angle, then I go across the side this way and then come back on it this way. So that's EDC. Oh, and the reason is by angle, side, angle. Very similar problem where you have vertical angles here in the middle. So I'll just go ahead and mark those as single angles. Now, if I look at the order here, this is angle, angle, side. Angle, angle, side. So yes, they are congruent to each other. I'm going to go R to S to T, which is the same thing as U to V to T. So triangle RST is congruent to triangle UVT. And the reason is angle, angle, side. Because it's angle, angle, and a side. Okay, you guys, that's all I got for us today. Ask me questions about the formative.